Welcome to 8-9. How can you solve a system of equations when one equation is linear and the other is quadratic? I'm going to show you. Quadratic, we mean it's x squared. Linear, it's x to the first. So here we have a system. Quadratic and linear. So the first way that I'd go about solving that is I would actually just graph it. This will be a straight line. Think of our arithmetic sequence. Our zero term is 48, and it goes down by -8 every time. So we put the intersection at -48, it's going to go down by 8. So there is my f of x. Now, my g of x, it's in vertex form. So I go over to my vertex at 232. So it's 232. And it looks like they're going to intersect right there. And now I need to stretch it by a factor of 2. So instead of going over 1, down 1, I would go over 1, down 2. And there's where it's going to intersect there. Now I would go over 2, and instead of going down 4, it's going to go down 8. So my intersections on these two graphs are at 2, 32, and at 3, 324. So for the x values 2 and 3, I should have equal solutions. Come back over here and I can plug those in. When x equals 2, -8 times 2 is -16, plus 48 equals 32. So that was f of x. Does that make sense? That it would equal 32 when I plug in 2. That's what that means. Now I plug it into the g of x. -2 times 2 minus 2 squared plus 32. 2 minus 2 is 0. 0 squared is 0 times -2 is 0. So that all wipes out and we get 32. Again, that should make sense according to the graph. Now we plug in 3. What should we get when we plug in 3? 24. 3 times -8 is -24. -24 plus 48 is positive 24. So we do get 24 with 324 there, or with 3 plugged in. Now we plug in 3 here. 3 minus 2 is 1. 1 squared is 1 times -2 is -2. That one does not work, does it? 3 minus 1 is 1, squared is 1, times -2 is -2, plus 32 is 30. Good thing we plugged that in. So that one, if I'm looking right, is not working. Yeah, that one does not work. So that was a good estimate, but it's not quite right. We do have 1 at 32. So the next thing that I would honestly do is I would plug these into the graph, y1 and y2, and I would take the trace button and go out on this until you get to that second intersection. See what it is. It's not exactly at 3. It's going to be slightly off from there, and it's going to be between 2 and 3 probably. Okay? mind's eye, picture how many solutions are in the system, okay? So let's just picture this, because it's important to know whether you have one solution, two solutions, what, or how many there could be. So in your mind's eye, g of x is 1. So hopefully you're picturing a straight line going right across here that's g of x. The vertex of f of x is 4, 1. So you would go to the right 4 and up to 1. How many solutions do we have? Remember, solutions are the shared points of the two graphs. And there's the vertex on this graph, that's your minimum point. It happens to lay on the line. So if you said there's one solution, you're right. Now, how can you modify one item up there to change the number of solutions? Well, when they're in this kind of an equation, you could actually even solve it. X minus 4 squared plus 1 equals 1. What's creating only one solution is that when we subtract here, we end up getting x minus 4 squared equals 0, and the square root of 0 is 0. So all that we're saying is that we want to change this to change the number of solutions. All we need to do is change this number or change this number. Looking at the graph, we're either going to take this u and go down to create 2 solutions. In other words, take this down. Or we could take this and go up to create 0 solutions, because it would be up here. Then it wouldn't cross it. If it was at 5, when you subtract it, it would be a negative. That would be no real solutions. Your other option would be to leave this part alone and move this line up or down, creating 2 solutions, 1 solution, or no solution. So be prepared to be able to do that. Okay? Make sense of that. Ask questions if it doesn't make sense. How many different possible solutions are there in linear quadratic systems? We just showed you there's 2 solutions. When it intersects going across the u. Or there could be 1 if it's tangent. In other words, it just touches the curve. So that's 1 solution. Now I have had students do this. They draw the u and they draw the line up here and they forget that this goes on and on forever. That is not 0 solutions. Only this is if the line's behind the u, lower than the minimum, or if it's higher than the maximum. That would be 0 solutions. Okay? How would you solve this? Where it's got the decimal in there, I would immediately put it into my graphing calculator for y1 and y2, and then use the trace button to go out and see where they cross. Okay, have a great night, and I'll see you in class.